a very ugly fraction. We need the value of s if n is not equal to 4, and we can see that it's not equal to 4 so that this denominator doesn't end up 0, which is naughty, and n is not equal to 2/3. That also rules out a 0 in the denominator here. So they're just making it so that we don't have an undefined answer. Thank you, problem. Okay, so we need to figure out whether we can figure this out. Statement 1 tells us that x equals 1. And what we can tell initially is that, of course, this is going to be 1 plus some fraction over and 2 to the n minus 6. No matter what this exponent ends up being, no matter what n ends up being, x raised to any fraction, since it's 1, it's going to stay 1. The question really is what happens with the fraction in the numerator and the fraction in the denominator. And when we substitute it in, it's going to be a huge mess, but it ultimately comes out to equal 5n squared plus 9n plus 4 over 3n squared plus 9n plus 6. A big mess, and without a value for n, statement 1 isn't going to get us there. Again, we really did need both variables for this one. So statement 1 is out, and we get rid of a and d. Statement 2 tells us that n equals 3, and it seems like we might be headed for another mess like this, but we do need to be sure. And one thing we should notice immediately is that if n equals 3, x to the 2n minus 6, 2 times n, or 2 times 3 is 6. So this ends up being x to the 0 power. This x ends up being replaced entirely by a 1. And when we plug in n up here, 2n plus 1 ends up being, 7. And then the denominator also ends up canceling each other out, and we end up, I guess I'll put it over here, it ends up simplifying to being x plus 1 over 1 plus x. Whoops, 1 plus x, which is equal to 1. So having n, the other parts all cancel each other out sufficiently that we're able to determine that the actual value. So statement 2 is sufficient. Answer choice B.